Okay, here's the second problem that I wanted to do today. For this machine that has a pulley that has an 80-pound weight hanging from it, and we want to find out what the reactions are at E, A, and D. You'll notice that D and E are pins, so they have reactions in the X and Y direction, whereas A is a roller, so it only has a normal force. So I'm going to break this into components to see if I can solve this. I can start with that pulley. We have an 80-pound force that goes down, which means the tension this way also has to be 80 pounds. And so we would have reactions at the pins, which would be also 80 pounds and 80 pounds. Okay, so that doesn't give me a whole lot, but let's now look at, let's see, we can look at EB. So EB is going to have a reaction EX and an EY. It will have a tension. It's going to be equal and opposite, so 80 pounds. That's going to be at 1 foot, and this is 3 foot. And then we'll have a BY and a BX. Okay, so I have 1, 2, 3, 4 unknowns. So too many unknowns to do much with. So let's look then at my A. We'll call this here C. This is C. AC. Okay, so at A I have my AX. At B I'm going to have a BY and a BX. Notice I'm drawing them in the opposite direction. Then here at this end I'm going to have this pin. So I'm going to have equal and opposite. I'll have an 80-pound force this direction and an 80-pound force going down. Then at C, I'm going to have C, Y, and CX. But if we come back and look up here, what do we see about CD? There's a force applied here at C and one at D. So this is a two-force member. So this is what I was talking about in class, where the two force members are not always in mind. But because of that, I can replace this with one force, C, and I know the angle, because the angle is going to be, let's see, this is 4, this is 6, so it's going to be the inverse tangent of 4, 6. So this angle here, the inverse tangent, tan inverse of 2/3, which is 33.69 degrees. Okay, so that's this angle. All right, so now I have 1, 2, 3, 4 unknowns and still 3 equations. But let's do something here. Let's take the moment about B. All right, and that's going to be, so if we take the moment about here, A goes through it, this 80 goes through it, so we're just going to have these two forces. So we're going to have an 80-pound, which is this distance here is, let's see, go back up here. That's 3. This whole thing is 3, 6. So this is going to be 3 plus 1. So that's going to be 4 feet. And that will be negative. Plus C. And we want what? The sine of 33.69. To make this one here. And that's going to be positive. And the distance would be 3. And so I turn out with C is equal to 192 pounds. Oops, put up there. So now I know my C. And because I know my C, I also know my D. So if you come back up here, this C is going to be pulling in that direction. So my D reaction is going to be 192 pounds, just like that. All right, so if I come back here, if I did the sum of the forces, let's see, the sum of the forces in the Y direction has to be equal to 0. So we're going to get negative 80 plus 192 sine of 33.69 minus by. So by is going to be 26.6 repeating pounds. Now ax and bx I don't know because they're both, if I did that, I'd have to do some of the forces in the x direction. We'd have ax plus bx minus 80 plus 192 cosine of 33.69. So I have two unknowns and can't solve that. So I got to go somewhere else. But if I come back here, I can take that by that I solved and put it up in here. So I now know this is 26.6 pounds repeating. And so now I can use, knowing that, I can now take what the sum of the moments. So I'm going to solve here. I'm going to take the sum of the moments about E is equal to 0. And so I will have, let's see, 80 times 3 minus bx times 4 plus by, which is 26.6 repeating, times 3. And let's see, when I solve that, I have not actually done that, so let's see what I get for bx. I'm going to get 80 times 3 plus 26.666 times 3 divided by 4 is bx is going to be 80 pounds. Okay, so now that I know bx and by, I can also find ex and ey. So the sum of the forces in the x direction is equal to 0. So I have 80 minus bx, which is 80, plus ex, or bx. So ex is going to be 0. And the sum of the forces in the y direction is equal to 0. So I'm going to have by, which is 26.6 up, plus ey. So my ey turns out to be 26.6 pounds going down. So that's going to go down. All right. And then what else do we need to find? And we need to find ax. So, well, now we have bx, by, c. So we could do the sum of the forces in the x direction for this right here. And we get ax plus bx, which is 80, plus the x component of that, which is 192 cosine of 33.69 minus 80. So ax is going to be, ax turns out to be 160 pounds, but it's going in this direction. And I think that gives us everything that we needed. We needed the reactions at A, D, and E. So the reactions at E, just to summarize, reactions at E are going to be EX is equal to 0 and EY is equal to 26.6 pounds going down. A, we're going to have 160 pounds to the left, and D, we're going to have 192 pounds, and it's going to be at that angle of 33.69 degrees. So there's our reactions.